Hello and welcome back to the GCSE Help revision videos for maths. Today we'll be going over some not simple but trigonometry such as Pythagoras here and SOHCAHTOA. So for Pythagoras and for SOHCAHTOA we're going to need right angle triangles, so 90-degree angle in a triangle, so as we can see there. What we need in especially Pythagoras is to know our different letters A, B, and C. Now what we really need to know is C, because C is the hypotenuse. The hypotenuse is the longest length in this right angle triangle. You can normally see on a triangle which length it is. It would be this in this case. And what our quadratic formula tells us is that a squared plus b squared equals c squared. So remember that this would be a or b, and then this is always c, and we always need to get this right to be able to do the Pythagoras theorem. Now, to start us off this question, it's asking us, what is the hypotenuse? So this is fairly straightforward. What we're going to need to do is 4 squared plus 3 squared equals c squared. Now, if we do 4 squared on our calculator, it would give us 16. And 3 squared would give us 9. So 16 plus 9 equals 25. Now remember, 25 is equal to c squared. And from this, we can now square root 25 on our calculator and get c is equal to 5. So here, c would be equal to 5 centimeters. Another question that they may ask you is, you already have the hypotenuse and you're trying to find one of the smaller sides. So remember, the hypotenuse is always c. And this, let's just label it a. So we have 5 squared plus b squared equals 8 squared. So what we're going to need to do is rearrange the formula. 8 squared minus 5 squared is equal to b squared. 8 squared is 64 minus 25, which is 5 squared, would give us 64 minus 25 is 39. So remember, 39 is equal to b squared. So b would end up being square root of 39, which on our calculator will give us an answer of 6.24. 6.24 centimeters. So for our next topic of trigonometry, we're going to be using SOHCAHTOA to find angles as well as sides. So this can be used when you don't have the two different angles, like here and here, and you're trying to find the hypotenuse, for instance. And if you have an angle, remember, there's going to be the 90-degree angle as well as another angle to be able to use SOHCAHTOA. So what SOHCAHTOA consists of is you need to be able to label the sides correctly. So let's take this triangle for instance. We have 28 degrees. We have to remember, what is this pointing to? This will be the opposite. The opposite, so O, we're going to label it. Obviously, we have the hypotenuse, as everyone knows, and we also have the adjacent, which is attached to this angle. We can do it here as well. We have the hypotenuse here. Here we have the adjacent, and here we have the opposite. This could be a difficult thing to get your head around, but just try and label these sides, and you'll be all set to start doing the trigonometry and the SOHCAHTOA, because this can really help with the triangle, which I'm going to explain now. Now, the triangle consists of the 3 different triangles, SOHCAHTOA. The S stands for sine, the C stands for cos, and the T stands for tan. The rest of them, as we know, A, adjacent, H, hypotenuse, and O, opposite. So this can be used to find our different terms. All we have to do, let's take this first question for example. We have the opposite, we have the angle, and we're trying to find the hypotenuse. So we will cover the hypotenuse, and we'll do opposite, so 3 centimeters, over sine of our angle, 28, which will turn out to be 6.4. So 6.4 will be our new hypotenuse. We can continue doing this for the rest. So we need to find so for this one, we're gonna need to find the adjacent. So we have the hypotenuse, we have the angle, we have the adjacent. We cover the adjacent, and we do cos of 20 times 5. So cos 20 times 5 is equal to 4.69, 4.7, let's just say. And for the last one, we have the adjacent. We have the adjacent because it connects. We have the angle, and we're trying to find the opposite. So we cover the opposite, and we do tan 30 times by our 4 centimeters, which will give us an answer of 2.3. So it's pretty simple to understand, to get your head around. It might be a little bit harder, and this is why we need a lot of practice with different triangles. So now we get onto a more difficult problem, which is solving angles, real life angles, from our 2 side lengths. So imagine we have 2 sides and we need to find an angle. So what Pythagoras will do is it will show us what this side length is. But we need to find our angle. We need to find this angle. So what will we do? We'll see. What is the 6.4? The 6.4 is the hypotenuse. What is the 3 in terms of this angle? It's adjacent to this angle, as we can see. Now what we're going to do with this information is we know that it's this triangle. So what we're going to put into our calculator is cos to the -1 of the 3 over 6.4. So you can find this cos to the -1 on the Casio calculator. You will need to click shift and then cos. You'll need to click shift and then cos to give you cos to the -1, and then inside the brackets you will do 3 over 6.4 to give us an answer of 62.05 degrees. Lastly, let's move on to a bit of application, into a bit of harder style questions, and so what we have here is a right angle triangular prism. So remember, we have our right angles right there. We have a right angle right there. And we are asked to calculate the angle AFB. So imagine that this is the angle that we're trying to calculate. So let me draw that in straighter line really quickly. So we have AFB. Now, what is this question giving us? It's giving us these 2 side lengths. So what are we going to do with these 2 side lengths, with 40 and 25? We need to find the hypotenuse here. So we're going to use our Pythagoras, a squared plus b squared equals c squared, to give 25 squared plus 40 squared equals c squared. 25 squared plus 40 squared is giving us 2,225. We are going to square root 2,225 to give us an answer of 47.17. So what it's really trying to find here is this angle right here, right? So we're going to need all the side lengths we can get to then use SOHCAHTOA to try and find it out. So what other side length can we get, do you think? We already have this side length, and now we have 47.17. So that's really all we need, because we know that this is a right angle triangle, and that's what we need. If we can get our image right here, our SOHCAHTOA triangle, we'll know that we have our This is our angle that we need to find. This is our angle. We have our adjacent here, and we have our opposite here. So what we're going to simply do is use TOA. So we're going to use tan to the -1 because we're trying to find an angle, as always. And we're going to do opposite over adjacent. So 18 over 47.17, which will give us a final answer of tan to the -1. Put this in your calculator. 18 over 47.17 is giving us an answer of 20.89 degrees, and that will be our final answer. So a little bit of application, a little bit of using both the Pythagoras theorem as well as SOHCAHTOA to try and find our angle. Tan to the -1, we're incorporating all of that, and I hope you guys enjoyed this video. It was a good one, and subscribe.